Okay, so today we are looking at the pigeonhole principle. So our learning intention is to gain the knowledge of what the pigeonhole principle is, and to gain the skill on how to use this principle to solve problems. So we'll be successful if we can recall what the pigeonhole principle is, and we can correctly apply the principle. So if we can figure out what are pigeons and which are pigeonholes. Okay. So basically, the pigeonhole principle is a way of counting. It's a counting technique. So imagine I have six pigeonholes. So if I have 6 pigeons, I can put one pigeon into each hole. But if I said I had 7 pigeons, then at least one of the pigeonholes would have 2 pigeons in it. Okay, so if n plus 1 or more pigeons, so for example this one, we had 7 pigeons, are placed into n pigeonholes, so if there's at least one or more pigeons, then there are pigeonholes, then at least one pigeonhole must contain 2 or more pigeons. Okay, so if n plus 1 or more pigeons are placed into n pigeonholes, then at least one pigeonhole must contain 2 or more pigeons. Okay, so it also means that if n items are placed into k containers, where n is larger than k, then at least one container will have at least n divided by k items. Let's do some examples. So, example 1, how many cards from a standard deck of cards to make sure that you select 2 cards of the same suit? Well, in this situation, there are 4 suits. So there's the hearts, there's diamonds, clubs and spades in a deck of cards. So how many cards do I need to select? If I'm selecting one card at a time, must I select in order to get 2 cards of the same suit? So imagine if I have, I take out one card, and let's say the first card was hearts, and the second card I took out was a diamond. If I was really lucky and I got another card out, that was a spade, and took one more out. I was really lucky and got one of each, so that was a club. Then I'll need to take out one more. So my 5th card would be one out of either one, it doesn't matter. But I'd have at least 2 cards of the same. So in this case, the pigeonholes I'll label that as K, were the suits. And the pigeons, in this case, and we'll label that N, was the cards. Okay, so in this case, I need to take out at least 5 cards to have at least 2 cards, 2 of the same suit. Okay. Or in other words, I need to have n plus 1. So if I've got 4 suits, I'd need to have n plus 1. I'd have to go k plus 1. Okay. Let's think about part 2. If we selected 5 cards from a deck again, at least how many must be of the same suit. Okay, so in this case, our pigeons, which we're going to label it as N, that's 5. We've got 5 cards, and this the holes, or K, is 4, because the same number of suits. So there must be at least 2 cards of the same suit. So N divided by K equals 5 over 4, which is the same as 1 1/4. Yep. So I've got 5 cards from the deck. How much must be of the same suit? Using this principle, N divided by K, so 5 divided by 4 gives me 1 1/4. We always round up to the nearest whole number. Yeah, so that's really important. Yep. So we need to have at least 2 cards will be of the same deck, with the same suit. Alright, question 3. If there are 3 pairs of socks in a drawer, black, white and grey, and they are loose, so we've got black, white and grey, how many socks must be selected from the drawer to have the same colour? So in this case, what we're going to call the pigeons, they're the number of socks. So we've got 6 socks. And the pigeonholes are the colours. And we've got 3 colours. Okay, how many socks must be selected from a drawer to have the same colour? Well, we want to have K plus 1. We want to have one more of the colours. Yeah. So in this case, we need to select four. So 4 socks to have a pair of the same colours. Okay. Question 4. We want to show that one box will have more than 1 tennis ball if we were to try to put 3 tennis balls into 2 boxes. So let's say we have box 1 and box 2. Okay, so I've got 3 tennis balls. I can put 3 in box 1, and if I did that, none will go into box 2. Alternatively, I could put 2 into box 1 and 1 tennis ball in box 2, or 1 tennis ball in box 1, 2 in box 2, or none in box 1 and 3 in box 2. So in this situation, we have N, so the pigeons is the tennis balls. K, the pigeonholes, is the boxes. Okay. And then, sorry, there's 3 tennis balls, not 6. So then N divided by K is 3 over 2, which is 1 1/2. So if we round up, so to 2, so there these 2 balls in one box. Okay, question 5. There are 14 people in an office. Is it possible to have at least 2 people that will have been born in the same month? So in this case, the pigeons, or N, is 14 people. The K, or the pigeonholes, is 12 because there's 12 months. N divided by K is 14 over 12. Sorry about that. 14 over 12. Well, that's 1 and 1/6. So we're going to round up to 2. So yes, it is possible that out of the 14 people, at least 2 will have been born in the same month. Okay, question 6. There are 500 people attending a conference in a city with 120 suburbs. Is it possible that at least 2 people come from the same suburb, or if 3 people come from the same suburb? So, because there's 120 suburbs, if we had 2 people, we would have to have, well, at least 2 people would have to have 120. So the pigeonholes is 120. So if I have one more, if I have 121, then we know that would mean that there would be 2 people coming from the same suburb. And because 121 is less than 500, this is possible. So here for 3 people, well, we've got 120, so that's the first lot of people that go through. 120 is the second lot of people, and we want 1 more than that, yeah, because at least 3 people. That's going to be 241, yeah, which is still less than 500, so yes, this is possible. On a side note, if we wanted to figure out how many people it would be, we would go, so N is 500, K is 120, N over K is 500 over 120, which is equal to 4 1/6. And if we're going to round up, so we'll have at least 5 people from the same suburb. Okay. Last question. We've got 75 conference attendees, and they'll be split into 7 groups. If there are at least X people in each group, what is the value of X? Okay, so here we have the conference people as being our pigeons. So there's 75 attendees. We're going to split them into 7 groups. So the K, or the pigeonholes, are the groups. If we go N divided by K, that's 75 over 7. That is 10.7. And then we're going to round up to 11. So at least 1 group will have 11 people. Okay, and then that's the pigeonhole principle. So to reiterate, the pigeonhole principle is it's a counting technique. It states if n plus 1 or more pigeons are placed into n pigeonholes, then at least one pigeon must contain 2 or more pigeons. Thank you very much.